Today's lesson is on basic exponential power rules. The first power rule we're going to look at as multiplying powers. The rule is when you multiply, you add your powers. So x to the fifth times x to the second. Well, 5 plus 2 is 7. So this would be x to the seventh. The reason behind that is because this x to the fifth is like I have, well, it is that I have 5 x's. And this x to the second means I have 2 x's. So now how many x's do I have altogether? I have 7. So I have x to the 7th. But the basic rule is when you multiply, you add your powers. So this would be a to the 4th. And this would be x to the 5th and y to the 5th. And this would be a to the 7th and b to the 4th. Now on this one, because we have numbers in the front, you're going to multiply your numbers just like normal. So 3 times -2 is a -6. That's same old, same old. But now we're going to apply our power rules to this. So this would be x to the, remember when you multiply, you add your powers. So x to the 6th, and then y to the 3rd stays put because there are no other y's. So number 6, I'm going to multiply 5 times 2 and get 10. And then this would be a to the 8th and b to the 6th. Number 7, I'm going to multiply and I'm going to get a positive 8. X to the 4th, y to the 5th. And number 8, -6 times 3 is a -18. A to the 2nd and b to the 3rd. Okay, now these are different because we have a power to a power. So when you do that, you're going to multiply, and here's why. This is saying that I have 2 x to the thirds. So I have an x to the 3rd and an x to the 3rd. And when you multiply, you add your powers. So that would be x to the 6th. But if you want to skip this step, which is totally fine, then when you have a power to a power, you multiply. So this would be a to the 15th, and x to the 4th, and y to the 8th. And x to the 5th, because there's a 1 right there, and y to the 15th. Now this is where it gets a little bit more tricky because now we have a number in the front. This is not 2 times 4 because this is not a power. This is a 2. And 2 to the 4th means 2 times 2 times 2 times 2. Now you have a button on your calculator you can push. You can do 2 to the 4th, which is fine. Or you can multiply it out in your head. 2 times 2 is 4, and 4 times 2 is 8. 8 times 2 is 16. And if you do the 2 to the 4th button on your calculator, you will get a 16. And then a to the, all right, remember when it's a power to a power, you multiply. So you've got to really keep straight what your rules are. So this is a -4th to the 3rd power. Because it's an odd power, this negative is going to stay put. If it was an even power, like in the next problem, the negative is going to go away. Because if you have an odd number of negatives, the negative stays. And if you have an even number of negatives, the negative is going to go. 4 cubed is not a 12. It's not 4 times 3. It's 4 times 4 times 4. So you can punch that in on your calculator, and that gives you a 64. And then x to the, and power to a power, you multiply. So that'd be a 6. Number 7, I have a negative to an even power, so it's going to go away and become a positive. And then 3 squared is not 6. It's 9. And then a to the, multiply your small numbers, so that'd be a 6. 5 squared is a 25. And then power to a power, you multiply, so that'd be x to the 12th, y to the 2nd. When you divide, you subtract your powers, and here's why. X to the 3rd means I have 3 x's on the top, and x to the 2nd means I have 2 x's on the bottom, and then check it out. These can cancel, leaving me with x to the 1st on the top. But instead of doing all that, you can just subtract your powers. But look at number 2. This means I have 5 a's on the top and 7 a's on the bottom. So when I cancel, yeah, I'm going to get a 2. I'm going to get a squared. The question is, where's it going to be? And it's going to be on the bottom because that's where I had more a's to begin with. So when you subtract, don't ever give me a negative answer. Just tell me how many are left and where would they be. So for number 3, how many would be left? 4. And where would they be? On the bottom, because that's where I have more to begin with. Okay, x's. Now just look at your x's. How many are left? 3. And where would they be? On the top, because that's where I have more to begin with. Y cubed and y. So that's going to give me a y squared, and it's going to be on the top because that's where I have more to begin with. Number 5, I'm going to have an a squared left, but it's going to be on the bottom because that's where I have more to begin with. And then my b's completely cancel because they're the same, so they're gone. So all I have left is 1 over a squared. X's, I have 1 left on the bottom, and the little y cubed is just hanging out on top. Now when you get to number 7, be careful. Don't apply the power rules to things that aren't powers. This is just 8 divided by 2, so that would be a 4 on top. And then x's, how many are left and where would they be? 1 on the top. Number 8, 4 and 12, if I reduce, I'm going to get a 3 on the bottom because that's where my bigger number is. X's, let's see, I've got 3 on top and 1 on the bottom, so 2 on top. And y's, I have 6 on top and 2 on the bottom, so that's going to give me 4 on the top. The 0 power rule is wonderful, super easy, because it takes everything and that's raised to the 0 power and turns it into a 1. So x to the 0 power is a 1, not x to the 1, just 1. 4y squared, all raised to the 0 power, is a 1. Now number 3, the whole thing doesn't turn to a 1 because the whole thing is not to the 0 power. The only part that's to the 0 power is the x. So he turns into a 1. But I still have a 6 and a y cubed. So what do I do with this 1? Well, this is all tied together with multiplication. 6 times 1 is just a 6. And then y cubed. So basically, you can think about it like this guy goes to a 1, and the 1 just gets absorbed because it's multiplication, and multiplying by 1 doesn't change anything. So apply that to number 4. What part of this is going to turn into a 1? This guy right here. So he goes to a 1, but 1 times everything that's there is just everything that's there. Now number 5 is different. This whole thing is raised to the 0 power. So the whole thing turns into a 1. All right, negative power rules. This is the last rule we've got to learn today. Negative power rules, I want you to think of them as being unhappy. If it's a negative power, it's unhappy. And your job is to make it happy. Well, if your job is to make somebody happy, you need to know what they are unhappy about. Well, they are unhappy about where they are. So how are we going to make them happy? We're going to move them. Well, you have a choice. You can be on the top of the fraction or at the bottom of the fraction. Number 1, this x to the negative 2 is currently on top of the fraction, but it is unhappy. So we are going to move him, and when you move him to the bottom, he becomes happy. So his power, which goes with him, becomes positive. Unhappy, move him. Now number 3 is unhappy, but where's that one? That A is on the bottom, so we are going to move it to the top and make it happy. And the 1 there, if you want to put a 1 right here, that's fine. It does not change a thing. Number 4, the x to the 3rd, happy. Leave him alone. This one, unhappy, so we're going to move him. So the x to the 3rd stays put, and the y to the negative 2 moves to the bottom and becomes positive because now it's happy. Okay, unhappy, so we're going to move him to the bottom. And you can put 3 to the 1 if you want to, even though 3 to the 1 is just 3. Number 6, unhappy, move him. Now number 7, unhappy, move him. Now what's different about this one? Can we do 4 squared? Like, can you tell me what 4 squared is? That's 16. So we wouldn't leave it like that. We would write it like that. So a little cleaning up afterwards. Same thing with this one. Unhappy, gonna move him, becomes positive, and now square him. Okay, number 9, unhappy, move him to the top. And you can put 4 to the 1 if you want to, but that's just a 4. Unhappy, move him. Unhappy, move him, which gives you 25. Okay, so now we've learned all these rules, so let's put them all together. So let's remember, when you multiply, you add your powers. When you have a power to a power, you multiply. And when you divide, you subtract. And negative exponents, you move. And anything that's raised to a 0 power becomes a 1. So number 1, we are multiplying. So I have x to the, when I multiply, add my powers. So x to the 4th, y to the 9th. Number 2, I am dividing, so I subtract. So you say, how many are left and where would they be? That would be a squared on top, b squared on the bottom. Number 3, first I need to do negative 3 cubed. So it's an odd power, so the negative stays. And 3 cubed is 27. And now I'm doing a power to a power, so this would be x, so I multiply, so this would be x to the 3rd, because there's a 1 there, and y to the 6th. Number 4, love number 4 because everything is raised to the 0 powers, that turns into a 1. This one's a negative exponent, so we're going to move it, make it happy. And then we're going to clean that up because we can. This one's unhappy, so we're going to move it to the bottom. So the key is, none of this is difficult at all, but the key is to take your time and know your rules. So just practice. Practice your rules, and this will be a piece of cake.